be good to kind of start off by, talking a little bit about yourself and maybe your institute. Can you share with us a little bit about the Institute of Competition Science, how you got started and what has the journey been so far for you?
Sure, yeah. So we're a what we would consider a incentivized innovation organization that we focus on how do we take really neat ideas and challenges that are out there in the world and incentivize people to try to come in and solve them and focus people's attention on these challenges. So I might be a little different from kind of the traditional 3D Heals person in that I'm not a research scientist. I don't actually do research on my own, but we focus on taking the work that research scientists are doing and focusing that. So identifying critical challenges in different areas of science and technology, and getting people to really come together in communities and focus their attention on those challenges. And we do that through incentivized innovation, which is basically using prizes and challenges, competitions to help draw people's attention to it. And it's not just the researchers that we're bringing attention to this through, but the public. So we take these challenge topics and try to bring more public attention to them so it can draw some uh, more funding, more support, just more interest in the need to solve these challenges. Because a lot of times, the research community does a really good job at solving the challenge itself, but they do a really poor job at telling the story about it. So that's another thing that groups like my organization can come in and support with. So that's what we focus on is
Mhm.
drawing that attention for people to these critical science and technology challenges, and then rewarding the scientists to solve them. And so it's kind of another funding model as well as just doing the traditional grants and investments, but it has a lot of other benefits to it as well.
Yeah, I think it's a really exciting concept that you have there. And, I imagine that you work with a very diverse group of people in terms of age group and also maybe the areas that they might be at. Could you maybe give a couple of examples of some of the really exciting projects for you, perhaps personally, that you have undertaken and, want to share about?
Sure, definitely. Yeah, we've done a lot of really, to me, really exciting projects, and that's where a lot of our work, kind of shines is in helping to highlight and tell the stories of the work that the researchers and the innovators are doing. So
Mhm.
we've done a number of projects with NASA that are really exciting for us. So we've done some other engineering challenges that are really neat. So a few years ago, we put on a challenge that was a NASA competition for energy storage, and that was a really exciting one to do some new innovative energy storage programs. Uh, in the bioengineering space, we started our work on a liver engineering prize,
Mm.
and that was an interesting one because it was really ambitious and
Mm.
probably a little too ambitious for where the research community was. So that was something where we kind of stretched our limits a little bit and said, hey, let's really try to push out the envelope on what people can do, and we
Right.
learned that it was probably just too far for what could reasonably be done in the time period that we had. So we had to pull that one back, and then we morphed it. I mean, a lot of really great things came out of that though, because we were able to build up a roadmap of bioengineering challenges out of that liver engineering challenge. So we were able to work with the scientific community at the time to develop this roadmap of 13 challenge topics that the bioengineering community felt were really critical to solve in order to get to the point where you could engineer tissues and organs that people could actually use in the clinic. So to replace lost or damaged tissues or organs that
Sure.
patients have. So from that roadmap, we were then able to work with NASA on another challenge. That's one of the main ones that we have going on now. that I'm sure we'll talk more about with the summit that comes up. But we were able to use that roadmap to identify. We had 13 challenge topics, and we
Mm.
presented those to NASA, which might have been a non-traditional organization for bioengineering to go to, but NASA got really interested in how some of these topics could be used in future human spaceflight, but also in looking at how microgravity and the use
Mm.
of outer space could help accelerate bioengineering topics. So we partnered with NASA to launch the Vascular Tissue Challenge, which is a challenge uh, to create the ability to have thick vascularized tissues engineered in the lab
Mm.
that could then down the line be used in the clinic. But right now it's just a laboratory work for this challenge to have, but it has to be a thin, a centimeter thick tissue, so much thicker than any bioengineering
Mm.
group has been able to do. And actually produce the functional results of that tissue. So not just be living cells, but actually have function that a equivalent
Right.
organ would produce in the human. So we're really excited about that one, and yeah, NASA's been a great partner coming together to work with, and we're in our final year of that challenge now. So we've got a lot of teams that are really close to actually winning it. So it's really exciting for that one.
Yeah, it sounds like it's been a long journey or a long road for you guys in terms of working on this project. So I imagine that must have been some challenges or success or failures that you have encountered. Would you mind sharing a specific example of a success or a failure that that the team has encountered in this project, and maybe what are some of the key takeaways that you have learned?
Yeah, well, I think for us in the management side of things, I mean, we our successes and failures are kind of on the program design, program management, side of
Right.
that. Well, how do we incentivize people to want to get behind these researchers and want
Right.
to focus their attention on these challenge topics that our community has found so critical. So, one of the kind of I guess failures that we've been learning from that I mentioned earlier was the liver engineering challenge.
Mm.
So this was one that we were really excited about, when we started things, and I think the failure, in it was that we didn't do enough research with the academic community in
Mm.
designing the challenge, and to identify the hurdle, So
Mm. Right.
because there's kind of that sweet spot. There's that Goldilocks spot with
Mm.
the defining what the hurdle or the challenge is.
Right.
So you can't be too ambitious that nobody can actually do it, but you
Right.
don't want to be too easy because then it's anyone can do it and it's not a
Right.
big hurdle. So there's finding that Goldilocks spot that's really important, and we weren't able to do that with the liver engineering prize. We were too
Mm.
ambitious in developing that. So the research community kind of looked at it and said, well, this is great, but we need 10 or $20 million in
Right.
10 years in order to do that. So we were putting up $1 million prize with that one, and
Right.
it just there wasn't a right match for it.
Right.
Um, but then we were able to learn and work with the research community to then define that roadmap of the challenge
Mm.
topics that they did see as critical milestones that could be done within the next 3 to 5 years. Uh,
Right.
so developing those roadmap topics was really important to us, and that was something that we were actually able to do through a White House summit that we hosted with folks at the Office of Science and Technology Policy. This was years ago,
Sure.
and from that we were able to bring the community together with that workshop and define those challenge topics. So, kind of out of the failure of the liver engineering prize, we were able to really bring that community together a lot more,
Mm.
and from that develop the challenge topics, and then create the vascular tissue challenge with NASA as a partner. And now we've got this great list of 13 kind of overarching challenge topics that the bioengineering community thinks are the critical hurdles towards getting to the point where we can put engineered tissues and livers and organs, into a patient that needs them.
Right.
So hopefully now we have this whole network of challenge topics that we can go to other partners and launch new competitions and new challenges to bring the research community together around not only the vascular tissue challenge, but the 12 other ones that are out there as well, so that we can build this whole community and network of uh, rewards, for the
Yeah.
research industry that can center their attention around those critical milestones and getting to the point where we can solve those and then say, hey, now we've been able to solve this one, let's go on to the next one and the next one. And
Right.
have all of those done, we'll be able to look back and say, hey, we've now gotten to the point where we can take bioprinted or engineered organs and tissues and actually use them in the clinic. And that will be just a revolution. That'll be amazing. So that's
Yeah, I think,
where we're going.
yeah, definitely. I think, something like tissue engineering, bioprinting, it's the problem is so complex that you often need resources and expertise from a variety of different fields. And I think having a platform such as yours to do that, to facilitate that conversation and discussion, is really a great way to get things rolling and get things started. So kudos to that for building such a good network and community for us. Um, Looking forward, what are some of the challenges that you foresee in the next 3 to 5 years that you guys will be facing? Could you share a little bit about what you're going through right
Yeah,
now?
I think as with it seems, most of the research world, funding is just the biggest issue with all of this.
Right.
That there's just not enough funding going into researching these topics, and they're really important topics. So that's one of the things that we're trying to bring more attention to with
Right.
challenges like this is not only the need for more funding, but also find innovative ways of bringing more people into supporting this research. So I think, of course, there's lots of challenges with the research itself, and that's what the roadmap is meant to address, is to identify what those challenges are. But the as far as what we deal with and what we see for the overall community of research and biofabrication, 3D printed bioprinting, and bioengineering, is that people, I guess there's two sides to the challenges. The one side is that the public doesn't understand where the science is and how important solving these challenges could be, what it could do. So having that public involvement and the public communication, I think, is really important, because getting more people in the public to understand what this research and solving these challenges could do. I mean, it's not just sitting in a lab, and doing theoretical research. This is real research that could impact healthcare and could revolutionize the way healthcare is done. I mean, if right now 200,000 people are sitting on the organ donor wait list, so if we can 3D bioprint an organ and give it to them to save their life, that's going to revolutionize the way we deal with healthcare. So telling that story to the public is a really big need. Uh, the other side of it is the funding side, and bringing more resources to help the research community solve these challenges, because it takes time. It takes time and money to do the experiments, and each of the experiments is not cheap. I mean, they can cost, on the low end, hundreds of thousands of dollars; on the high end, tens of millions of dollars. So
Mhm.
the
Yeah.
funding is definitely a big need, and that's one of the things that we're trying to kind of play a role in bringing more attention to that need, and then finding innovative ways to get more people to support the researchers that need it.
Yeah, that's very true. I think definitely, a lot of these challenges, as you said, sometimes it's needing more money to go into solving these problems that will accelerate the timeline for us to get there. And I think that's definitely an important component in making all this a reality within our lifetimes, hopefully.
Yeah, exactly.
Josh, I know you've taken a very unique path in your career. Would you mind sharing? And I'm sure all the some of the younger folks might be interested to hear a little bit why you took this path, and maybe what are some of the risks you took in your career that you think has been rewarding?
Yeah, that's an interesting one. I think as far as the risks, yeah, I took like say a very non-traditional path in my career. That I actually started out as a research scientist in education. I was uh, educated at MIT in planetary science, so studying completely different things. I was researching lunar exploration, Mars exploration, trying to figure out better ways to get people exploring space. Uh, so I still have a very fond love of everything space exploration, but I kind of realized as I was going through my graduate career that being the research scientist wasn't really what I wanted to do. I wanted to be
Yeah.
more involved in the community around getting people excited about these things and being kind of involved in the world from that side. So I left the research path to join a nonprofit foundation called the X Prize Foundation. And the X Prize Foundation is really where I got started in understanding the role of innovation and particularly incentivized innovation in science and technology. So the X Prize was kind of the pioneer in the modern world of uh, large scale grand challenge prizes. They started in the early 2000s with a $10 million prize for the first privately funded manned spaceflight.
Mm.
And that was done in 2004. So since then, they've gone on to a number of other kind of revolutionary scale prizes, and that was where I got my start, just understanding uh, how these challenges and prizes can play such a big role uh, in the advancement and development of science and technology. So I got really interested in it from that side. So I always knew that science and tech was kind of my world and in my happy place, And
Yes.
so I was involved in things in the world of science and tech, but I really branched out from my first love of space exploration into many other fields of science and technology and started working on prizes and challenges in lots of different spaces. I mentioned energy storage was one that we did. Of course, the biofabrication, bioengineering is really a big one that we're really heavily invested in now.
Mm.
And but it's not just those. It's we've done work in education is a really big space that we focus on. Again, in the kind of science tech education is a space that we do a lot of work on. So I've done just a little bit of it has been just kind of feeling out where I'm excited about things and then following that passion, following the drive of like what just gets me out of bed every morning and what
Yeah.
I get excited about. And um, I've been lucky enough that a lot of great opportunities have just kind of come across my path. But I think a
Mm.
lot of it is also just being able to take the risk to follow those opportunities.
Right.
I think a lot of people are still very risk adverse in
Hmm.
what they feel like they can or should do.
Sure.
And I think that's probably one of the things that has led to the most uh, success and value in my kind of non-traditional career path is just
Sure. Yeah.
being willing and able to take those risks.
Yeah. Yeah.
That
Definitely.
would
I
be
think
one
it
thing
takes,
that I'd say for the students. Yeah.
yeah, I think definitely that takes a lot of courage and be willing to take the risk and explore, opportunities that you may not know all the answers. So I think that's great. Awesome. Cool. Any last words or thoughts to the community before we kind of end this interview? I know we're all very excited for the 3D Heals, which is in 2 weeks. So
Yeah,
looking
definitely.
forward to that. But do you have any last things that you want to share to
No,
the
I
community
think
before we end?
I mean I'm really excited to talk with folks at the virtual summit and figure out if there's ways that we can be involved in helping to advance some of the great things that people are doing. That's really our role is playing the position where we can help accelerate all of the technologies that people are working on. So I'm really excited to see and hear from people about what kinds of things are going on in the kind of 3D heals, healthcare space with because I've gotten to know a lot of great researchers in the biofabrication space,
Hmm.
but I don't know a lot about from the other side of what 3D printing is doing in healthcare, and I'm really excited about that. So I'm looking forward to it.
Yeah, absolutely. Yeah, I think we have a pretty good program out there. Jenny just sent out the program last week, so I'm really looking forward to meeting everyone virtually. So
I am
yeah,
safely
thank you so
isolated in
much.
our home offices here.